Just to begin with here, the answer to question number 20 in the assigned problem set from Friday should be 3-4. I think I had 3-6 there. It should be 3-4. See a couple of you nodding your heads in agreement there because you got that. What we were doing on Friday was studying what's called the Binomial Theorem, which is a tool in mathematics used to take a binomial power, which means a binomial like x plus y. We know it doesn't have to be x and y, and it could be minus, and there's variations to that, raised to an exponent. So x plus y raised to an exponent of n is called a binomial power. The things that you need to know to be successful in expanding a binomial power or finding a term in a binomial power or solving any problem involving this, the first thing you need to know is that you're always going to get one more term than n. And that's very important for many problems. There was a problem that we were working on in Sabre Support this morning, and we needed to know the middle term when we had a binomial raised to the 10, I think it was. So in order to figure out what the middle term was, we had to first say, well, if it's raised to the 10, that means there are 11 terms. And then we had a fighting chance to find out which term would be the middle one. So we need to know that. How many of you, and I know you have limited experience with this, but your mind should be on this because you would have completed some of this for homework, I suppose, I hope. How many of you can either solve these problems by using this formula or just by using a recognition of a pattern? How many of you have a preference of one over the other? How many of you have a preference that's the formula? Okay, and that's usually the case with some people because it's definitive, right? You look at it, you say, well, this is what I need to do. How many of you just recognize the pattern and would prefer to use that? Okay, and that's some of you as well. I would suspect that many of you kind of flip back and forth from one to the other. But this pattern in a formula form says tk plus 1 equals n choose k times x to the n minus k times y to the k. The bottom line here is that k is what we call a key number, and each term in the expansion has its own individual key number. And you need to know how to put this all together to using patterns or this formula write out terms. So for example, if I said to you that we have 2x minus 3y and we are raising it to the 12, and a very basic kind of question would be, an entry-level question would be, what's the fourth term equal to? So you need to recognize that since it's the fourth term, we're talking about a key value for that term of 3. So if we start making a list, we know that x is 2x. I don't like putting it there. I'm going to put it over here. We know that for every term in this expansion, when we apply either the formula or the pattern out of our head, that x is actually 2x, that y in this example is actually negative 3y, and that n is 12 for every term. If you want to find the 10th term, the first term, second term, n is 12. And by the way, there will be 13 terms. So the idea here is knowing the key number for the fourth term is 3 allows you to solve the problem. And I'm going to solve it. I mean, I guess you can kind of say I'm using the formula, but I'm not looking at the formula. I just know from experience. I know from experience that that term, T4, will be 12 choose the key number. It will contain my x raised to an exponent. It will contain my y raised to an exponent. That's the key number. And I mean, again, you could look up here and you could go, well, he's just looking at this. Well, whether I am or I'm not, all that's important is I get the right answer. If you want to look directly at it, you can. And then I say to myself, this has to be a 9 because 9 plus 3 will give me the 12. Those two exponents have to add up to give n. And I'm not going to spend class time here simplifying this, but just verbally, the coefficient of this would be 12. I'll write this down, but I won't calculate it. The 12 choose 3, the 2 raised to the 9 and the negative 3 raised to the 3 are all going to contribute to the coefficient. So the coefficient is the product of all of those. And then, of course, you're going to have x to the 9, y to the 3. And you can simplify that. So you need to know how to use either the formula or patterns in order to find general terms. Every term in the expansion has the same x, y, and n, but once again, each term has a different value of k. I shouldn't need to say this, but I'll say it anyway. Clearly, this k is different than the k we've been dealing with regards to transformations, right? Okay. That's it. So we do have one more example that I would like to go through. However, before we do, it might be helpful to go over questions that people have from this assignment. Does anybody have any questions you would like me to go over? Markman? 13? So we're asked for a constant term here. And this question is not an entry-level question like I referred to before. If I give you a binomial and I say find the 6th term or find the 12th term or whatever, that's run-of-the-mill math. You identify x, you identify y, you identify n, then you figure out what value of k you need to find that term, and you just do it. This one is a little bit more involved. And the reason it's more involved is you're asked for the constant term. So first of all, constant term means that the variables, and the variables in this particular case are a, will be raised to the 0. It means that you're not going to have any variable component. You're only going to have a coefficient. So there are two ways we can find out k. Let me back up. We need to know k. We know x, right? X is actually 2a. We know y. Y is actually 1 over a. Or if you want to think of that as a to the negative 1, feel free. We know what n is. N is 8. Once again, and this is probably the 3rd or 4th time I've said this today, these 3 things are true for every term in the expansion. Whether you're going to find the first or the last or any term in between, that's true. What's different is each term has a k value. So there is some coefficient here. There is some number that this will be equal to. I shouldn't even do it that way. We will have no variables. A to the 0 is 1. We will have a coefficient in front of that a to the 0, and that's what we're after. But what we need to know is for this particular term, what is this term's k value? Because if you're going to use the formula or you're going to use the pattern recognition, you need to know k. So how do we do that? Well, this is one way you can do it, and I told you on Friday I would show you a different way today, and I'm going to use this example to do so. What you can do is you can write which term we're talking about here, term 1, term 2, term 3, and we can extend this table as much as we need to. And what I'm going to put in the other part of the table is the variable component. I'm not going to put in here what the term is. I'm just going to put what it will have for variables. So we know that the first term will always have x raised to the n, right? This is where I'm not really looking at the formula. I just know the first term has x raised to the n, and if you want to be, complete, it will have 1 over a, which is y, raised to the 0, okay? But the bottom line is we can look at that and we can say that's going to have a to the 8. A to the 8. A to the 8, everybody, is not a to the 0. Now, I do have a 2 in there as well, and I said I would only put the variable component, but I don't think that bothers you, right? This will contain a to the 8s, correct? I'm hesitant. I want to kind of erase that 2 because I do have variable component, but I think that would cause more confusion. I think you're fine with the fact that I'm not looking at the 2. My next term will have my x's raised to 1 less and my y's raised to 1 more. Now, what does that give me for a? Forget about the 2. I'm going to have a 2 to the 7. I'm also, by the way, in the second term going to have 8 choose 1. But what does that give me for a's? It gives me a to the 7 over a to the 1, which is still not a to the 0. Are you with me on this, Markman? And we just keep going. Now, you can, if you want, you can be very specific here and say this will be a to the 8. This will be a to the 6. Right? In terms, I didn't put equals because there's that 2 and there's other stuff there. But now, if you want, you can kind of stop doing what we've been doing and recognize that a is losing 2 exponent values each time, which means the third term will be a to the 4, the fourth term will be a to the 2, and then we will get a to the 0. So this is T3, T4, T5. And we've done all of that, everybody, so we can determine that it's the fifth term. So now we know k is 4, 1 less than the term number. So we have the answer to this now. And now we can go ahead and find the fourth term. So in other words, at this point in time, this question is an entry-level question because you know the value of k. I might have just said we can find the fourth term. If I did, I apologize. We can find the fifth term, which is k equals 4. Okay. So the term that we're after, which had better be a constant term, we'd better get a constant number out of this, will be n, which is 8. Choose our key value for the term, which is 4. We're going to have 2 times a. We're going to have 1 over a. The 1 over a, which is our y, is raised to the key value, which is 4. And our x is raised to 8 minus 4, which is 4, or it's raised to a number that when added to the key number gives you 8, which would mean it's 4. And you can see just by inspection here that you will get a to the 0. However, the answer to the question being, what is the coefficient? We have 8 choose 4. We have 2 raised to the 4. All of our a's combine to give a to the 0. So whatever 8 choose 4 times 2 to the 4 is our coefficient, the constant term. I'm going to show you an algebraic way to find k. And what this does is it takes everything out of the table. You don't use the table. And I think it's cleaner, but some students will struggle with it a little bit. The idea is whoops. This is how you find any term, right? And we know that x is actually 2a. Am I right? I don't know why I've forgotten it so quickly, but it's 2a. And we know that y is actually 1 over a. Or was it positive? Yeah. And we know that n is 8, but we don't know k. Well, let's put everything in there. Let's put everything in here. And we're going to have 8 choose k. We're going to have x to the 8 minus k. Well, we're going to have 2a to the 8 minus k. We're going to have y, which is 1 over a, to the k. Are you with me there? I've just substituted everything in, I know. But I know, everybody, I know that this is equal to the coefficient. What do I want to call the coefficient? I'm just going to say coefficient times a to the 0. I know that. I am after this being a to the 0, right? And some coefficient. But if I simplify what I have here, 8 choose k, I don't really care about that. 2 to the 8 minus k, I don't really care about that. You'll see why in a second. And I also have this 1 here. This is maybe overkill, but I do have the 1 to the k. And this is going to be the coefficient, right? Those are all of the constants. But then I'm going to have a to the 8 minus k over a to the k. Because 1 over a, quantity to the k, is 1 over a to the k. And this is my variable component. And I love this method. This is equal to our coefficient times a to the 0. But what this means, everybody, is that this is our coefficient. But more importantly, this is a to the 0. It has to be a to the 0. And we can go back to the lesson on solving exponential equations and say a to the 8 minus k over a to the k has to give a to the 0, and we can write everything in base a and compare the exponents. And I'm going to pause there for a second. I don't know if you remember, but remember me fumbling around with this table and saying, well, it's not really equal to that. There's another number, but I didn't want to erase that too. I don't need to do that anymore. I don't need to worry about, on a written response, trying to communicate what it is I'm doing or thinking, because the math speaks for itself here. This can be written as a to the 8 minus k, because I subtract the exponents when I divide common bases, powers with common bases. And this is equal to a to the 0. Well, those two exponents have to be equal. And I get 8 minus 2k, that's an 8, equals 0, and I solve that for k and get 4. And you can do this for any of them, for any of these problems like this. I want to go back here to a problem that we did last week. We did a constant one, so let's do this one. Like this was done. We completed this last week. In this expansion, which term has b cubed? And we did this table, and we reasoned out that b was dropping by 3 each time, and we figured that b cubed was the 6th term, so that meant k was 5, and then we were off and running. Do you remember doing that? I mean, maybe not specifically, but I'm not speaking Greek to you, right? You understand what I'm saying? So let's just keep in mind that k is 5 here. K is 5. I'll write this down over here. K is equal to 5. We could have found that by saying the following. That n, which is 9, choose k, which we don't know, times x raised to the 9 minus k times y raised to the k has to give us a coefficient times b cubed, because we're after the b cubed term. Well, the 9 choose k, the negative 3 to the k, those two things give us our coefficient. Our variable will be the b squared to the 9 minus k, and it will be an over b to the k, because that b in the y is on the bottom. And that has to be our variable component. And you might even argue, and I can buy the argument, you don't even really need to write equals. You can just say that's the term we're after, and then end up saying that b to the 2 times 9 minus k over b to the k, I'm just using a power of a power here, has to equal b cubed. Right? It has to equal b cubed, because that's the term we're after. So then we can write the left side of this exponential equation as b to the 18 minus 2k. That's what 2 times 9 minus k is. Minus k has to equal b to the 3. And then I can set the exponents equal to each other. It's clean. It's so clean. If you can handle it. And if you can't, that's fine. That's not a criticism. I'm just saying that we all have different ways of looking at things in math and different abilities, different strategies. So this means 18 minus 3k is equal to 3. So I add the 3k to the other side. I move the 3 over. Bam. I get k equals 5. I know I went very far afield from your question, but I've answered your question and I wanted to use it to explain how you could do these types of problems, find the missing value of k so you could proceed algebraically. Does anybody have any other questions? Yeah. Did you say 1, 7? Okay, so 17. So what is the middle term in this binomial expansion? You know, ultimately, so many of these questions come down to, unless you're asked, what is the 12th term or the 3rd term? Unless you're asked that, the problems boil down to, what is k? You need to find k. And we start off with the idea that if n is 8 here, we have 9 terms. And one way or another, you need to be able to figure out which of those 9 terms would be the one smack dab in the middle. And the way I look at it is this way. One of those 9 is in the middle. That means the other 8 are not middle terms. But that means the other 8 have to be equally distributed on both sides of the middle term. So I have to have 4 terms and then the middle term and another 4 terms, which means the middle term is the 5th term. Now, you know, if you want to you could draw 9 blanks to represent the 9 terms and then visually start knocking terms off of the left and the right until you're left with the middle, but it's the 5th term. So now what we know is that we're after the term where k is equal to 4 because the middle term is the 5th term, k is 1 less. So there's a couple of things you have to remember here. There's one more term than n, but k is 1 less than the term number you're after. Okay. I'm not going to write this down. I hope you can see that x is actually a squared and y is actually negative a cubed. N is 8. So this term, the 5th term, will be n, choose the key number, y, which is negative a cubed, raised to the key number. This is just how I think. And then x, which is a squared, raised to the number that when added to the key number gives me 8, which is n. That means these exponents are both 4. What we're going to get here is 8 choose 5. We're going to have a negative 1 to the 4. There's a negative 1 in front of the a cubed, right? But even though it's not going to do anything, it's still going to be positive after being applied with that power of an exponent of 4. We still need to think of it as negative 1 raised to the 4. And I could tell by the looks on a couple people's faces and just by your body language that I had written something down wrong. It's 8 choose 4. I was just getting ready to ask, what did I do wrong? Because I could tell by looking at a couple of your faces I did something wrong. I'm going to have a to the 8. 2 times 4 is 8. I'm going to have a to the 12. That's very helpful because now I know I'm going to get a to the 20. And I have to figure out what 8 choose 4 times negative 1 to the 4 is. Negative 1 to the 4 will be a positive number. So, you know, if I have confidence in what I've done, I should be able to just choose D because it's the only one with a to the 20 and it's the only one with a positive coefficient. So can you confirm, though, that 8 choose 4 is in fact 70? It is. Okay.